All right, I want to talk about chapter 1.2 in this video, or section 1.2. And my pen's not working. There we go. Chapter 1, section 2. Section 2 has to do with modeling. This is an important concept in physics. You'll hear us often say, you're never wrong to draw a picture in physics. Right, so introducing the idea of modeling is important here. So where do I want to start? A model is a simplified representation of a problem. The book goes on to talk about different types of models. It says things like a geometric model, where you take a real life situation and you describe it in terms of some geometry. If you've had a trig class, you probably remember something like a person looking at the top of a tree, and you know the angle that they're looking at and how far away they are from the tree. And you're asked something like, what's the height? Right? So here I've drawn, excuse me, a simple picture. If we were to change that into a geometric model, then we just change that to a simple sketch of what's going on. Right now we're representing a right triangle where the height is the height of the tree and the distance from the tree is the base of our triangle. And we're given the angle, right? The next type of model, it says is a simplification model. Really, all of these are a way to simplify. In particular, the example for a simplification model that we'll use the most is the point approximation. The book refers to it as a particle model in this chapter. You'll often hear physics professors call it point approximation. And what that means is if I'm talking about anything really, if I'm talking about a car, or I'm talking about a person on a skateboard, or I'm talking about a box sliding across the floor, we don't consider the shape of these objects, we just consider them as a single point where all the mass is located, and we talk about what happens to that point. And you may also hear this called center of mass. Right? Because that point would be located at the center of mass, and we consider the whole object as existing at that same point. The next one is analysis model. Again, these are all just simplifications. This is a way to describe the situation relevant to what you're interested in. Right, so you're only taking the descriptions that matter what you're talking about. If I'm talking about the motion of an object, then I don't care about the color of the object, those kinds of things. Right? You know, kind of trimming out unnecessary information. The last one it mentions in this section is structural models, which are important, but we probably won't use too much in this class because we mostly deal with macroscopic objects, and this is some things you might describe the lattice structure of a crystal as atoms connected by springs. One thing I have done in an introductory physics class is described a bow, like a bow and arrow, right, as a spring. A bow is surprisingly similar to a spring. So we can model a bow as a spring. And we can talk about the elastic energy stored in a bow, similar to the way that we do in a spring. So that's one type of structural model, where you're taking a real situation and you're describing it in terms of something that acts similarly to make it understandable, right? These are not springs connecting all your atoms, right? You have electromagnetic fields between the atoms that determine how they interact with each other. But a spring is a very good approximation. Okay, more important in this section than talking about the different types of models, because you'll use multiple models all the time. If you're using a structural model, you're also simplifying. You're also using analysis details. And you may be using a point approximation, right? So I think what's more important from this section is the discussion on representation. So how you represent and this goes to problem solving, right? In the book, it talks about first forming a mental picture. Right? Imagine the situation. If you're going to form a model and you're going to start trying to describe what's happening, you need to have a mental idea of what's going on. From that, you can draw a picture. And often then you'll simplify your picture. That's what I did above, right? I drew the person and the tree and the situation that was going on. And then I simplified that picture down to just the geometry. The next step there, you might do a graph. This might depend on what you're working on, right? If you've watched some of the other videos, I did a lot of motion graphs where I graphed position versus time, and velocity versus time, and acceleration versus time for several different situations. You might also be interested in a table just to organize your information. When we do projectile motion, we're going to have something moving in 2 dimensions, right? So we may consider an XY coordinate system, and you might use a table to sort variables in the X and in the Y so that you don't get them mixed up. Etc. We'll talk about that when we get to projectile motion. Just an idea of using a table there. And then, of course, mathematical. If we're going to get to something quantitative, we're eventually going to have to do some math, right? So that's kind of in there anytime that you're not just conceptualizing. So I think the takeaway from this section of the book is you're never wrong to draw a picture in physics. I know you say never, but I can't imagine a situation where a picture wouldn't be useful in physics. That may be a mental picture, and it may be one that you draw, but in general, I would always begin by drawing a picture.